Hello, hello. Can everyone hear me okay? We're good? Beautiful, beautiful. This works, that works. Right, so, as mentioned, this talk is, we'll get to the title, Faces and Data, that'll make sense later. But this talk is about user interfaces in science fiction. You're going to find out very soon that I am a huge nerd and I enjoy watching science fiction, but I'm usually looking at the screens. I'm obsessed with the user interfaces we see in science fiction. Just this design here from Star Trek is, I feel like the design itself has kind of gone in and out of style over the years, but does anyone else spend a lot of their time tapping on smooth black rectangles these days? I don't know, does this seem... this here is pretty much exactly what my mornings look like. I've got a cup of tea, Earl Grey, hot. I do actually have books, physical paper books in my apartments, but they're actually mostly there for aesthetics, and I do most of my reading on a tablet. So it's fascinating to me how science fiction has both shaped the world we live in and perhaps made predictions about it as well that have come true. Now, speaking as an Irish person, a little bit disappointed that they didn't all come true, but let's see what happens next year. So, Star Trek is one pretty popular example. It's also easy to talk about the Marvel movies. You've seen Marvel movies. Statistically, you've all seen Marvel movies, and you've seen these shiny holograms and people playing with them, and it's easy to kind of discount these as Marvel throwing lots of money at something to make it look shiny, but I actually think this acts as a bit of world building. It establishes this universe, the Marvel Cinematic Universe, as like our world, but shinier, a little bit more high-tech. Even acts as character building. This character here, Tony Stark, he really leans into this technology. You can see how he uses it, how it informs and shapes his thinking, how it quite literally becomes a part of him. Look, it's not subtle, okay? And not everything has to be big world-building or narrative informing user interfaces. One of my favorite little jokes is from The Hitchhiker's Guide to the Galaxy, the early 2000 movie and the book it was based on. There's a scene in which a character presses a button on an interface, and it responds by just saying, "Please do not push this button again." It's a little gag, but I like it. So, you probably have a favorite science fiction interface, something that stuck with you, something that buried its way into your mind and you just can't stop thinking about. What I want to do today is I want to look at 3 specific examples of user interfaces in science fiction and what we can learn from them. The first is from the movie Alien. There are going to be minor spoilers for the movie Alien here, but I'm going to play a very short clip from this movie. It's from a little bit later in the movie, where the main character, Ripley, she's running away from the alien. Sorry, again, spoilers, there's an alien in the movie Alien. And to try and deal with the alien, she decides to activate the self-destruct of the spaceship. So let's watch this.
emergency destruct system is now activated. The ship will detonate in T-minus 10 minutes. The option to override automatic detonation expires in T-minus 5 minutes.
I love everything about that scene. I mean, you've got this beautiful set of instructions here. Danger, emergency destruction system, big red and yellow text, very threatening, very serious looking. Now, one interesting note here is all of this is in English except the section in the corner, which is in Italian. So I don't know why they felt the need to allow space Italians to blow up this spaceship, but I guess they saw that as important. And then you've got these buttons. In the entire movie, these buttons are on the screen for 5 seconds. And look how much effort has gone into these. Some of these buttons are blank. Some of them have weird glyphs. We've got a frowny face up here. We've got an implosion, an explosion. Some of them just have nonsense words like hum, Shakti excess, or fly agaric, which is a type of mushroom, by the way. I mean, this interface looks so stressful. It's like, it reminds me of trying to book a meeting in Outlook. Incredible work has gone into this. I love it. And then you've got these cylinders that rise up out of the floor. These are supposed to evoke control rods in a nuclear reactor. The idea is that as they lift out of the reactor, it starts overheating and overloading, right? Now, spoilers for a little bit later, but the character, Ripley, she decides to reverse the self-destruct, and she has to do the whole thing in reverse, and they start slowly hissing into the floor, sinking down. And she has to throw herself into them, try to force them down faster. I find that fascinating because we spend, again, a lot of our time interacting with the world through smooth, black rectangles, very little tactile feedback. And this is an interface that is hyper-tactile, where the physicality of this interface actually adds to the tension in the scene. Really just amazing set design there. And then you've got this clock, this timer, this countdown. I was obsessed with this. I actually noticed something just as a little Easter egg in the movie Prometheus, which is a prequel to Alien. There's a little Easter egg where they use the same design. So I'll just show you this very.
3. All right, gentlemen, let's do this. Impact imminent.
Same timer. Sorry, spoilers for the movie Prometheus. That scene does not end well for Idris Elba. But I'm obsessed with this timer, right? I look at it and I think about it a lot because we use timers a lot, right? If you Google timer, you get this. You can just press the button and start the timer. If you use a tool like Miro or Mural, you have a timer like this. Who here has used one of these in a workshop? Of course you have. We have all used these. These are perfectly functional timers, but they're boring. So many, many years ago, I had a spare weekend, and I decided to build the clock from Alien. You can go and use it. It's called Mother Countdown because the computer's name in Alien is Mother. It's a thing, don't worry. Now, when I built this, I told all of my friends, all of my colleagues that I have built this cool timer and you can use it the next time you're doing a workshop. And most of my friends correctly either ignored me or told me to shut up. But one of my friends didn't. And she actually sent me this picture. So she was facilitating a hackathon. They had a big sort of final presentation and they had to prep everything just in time. So she used my timer to show the countdown. And there's two really important reasons, or two really important things you can learn from this picture. The first which was the reason she sent me this picture, is that it doesn't work on Internet Explorer. Fair, okay? However, my timer outlived Internet Explorer, so who's the real winner now? The other thing that I think you can learn from this picture is that this is not a very good timer. It's taking up all of this space, and the time is just over there. There's issues with contrast, of course, yes, but it's actually very difficult to tell how much time is left at a glance, even though it's counting down the milliseconds. At the time, I was doing a lot of physical in-person workshops, and these were quite common, right? I don't know if maybe some of you have used these. You just dial up, and it counts. Whoops, we've got this now. What does that mean? I'll just keep talking. It's going on like that. Oh, there we go. Okay, I'll go. You just smile. We'll have fun. Okay, so you dial this up and it counts down. And the thing about this is not precise at all. You cannot tell how many milliseconds you have left. You can only just about tell how many minutes you have left. But you can glance at this across the room and figure out how much time you have left. So I learned something really important spending a weekend or two building this timer, which is that timers are only really useful if they show you how much time is left. I'm not really a UX person, so maybe this is obvious to all of you, but I had to go through the experiment to learn it. So that was my first learning. The next user interface from science fiction I want to talk about briefly is Minority Report, right? Everyone, you may or may not have seen Minority Report, but at the time, everyone was loving Tom Cruise swiping. He had these special gloves that allowed him to swipe things across the screen and have all sorts of fun with it. And this actually became really, really popular. So I'm going to play a very short video. This is from 2011, a trade show.
At the Embedded Systems Expo, Toshiba Information Systems presented AirSwing, a user interface that can be operated via a camera. With AirSwing, a menu screen and a semi-transparent image of the user are shown on the display. The user can select content by shaking their hand while it is superimposed over buttons on the menu screen.
So, that was 2011, shortly after Minority Report. And Toshiba wasn't the only company that did this, but it's now 2025. So I assume everyone is enjoying their Toshiba AirSwings, right? How often do you use it? Is it like once a week, multiple times a day? Yeah, you don't have a Toshiba AirSwing because it turns out this is not a very good idea, okay? What happens every time a company builds something like this is people use it for a few minutes and they go, ooh, I can swipe, I'm like Tom Cruise in the movie. And then their arms get tired and they sit down and they go back to using a mouse and a keyboard. So Toshiba and many other companies invested huge amounts of money in building these prototypes, and they learned something very important, which is that people do not like waving their arms around. Interestingly, this is the reason that Apple and Steve Jobs in particular have given for not touchscreen laptop. Because apparently they built prototypes, people use it for a couple of minutes, and then they just go back to using it like a normal laptop. So you can actually see this in their Vision Pro, their VR goggles. This person here is actually tapping their fingers. And one of the big features of this headset is it's got cameras so it can look down and you do not need to lift your arms for it to see those interfaces. So people do not like waving their arms around, and that's something that is really important to understand when designing these sorts of interfaces. The final interface I want to talk about today is from the book Blindside. Has anyone here read the book Blindside? Just me, that's okay. So this is probably my favorite science fiction book. It's a very hard science fiction. It kind of aims for being a realistic, sort of scientifically accurate story. And it's a first contact story. The characters go out into space and they meet an alien. Stuff happens, right? I want to read to you two short passages from the book to get to a point about, obviously, a user interface. So the first is, suddenly, Rorschach snapped into view. There it was at last, naked even to human eyes. Imagine a crown of thorns, twisted, dark, and unreflective, grown too thickly tangled to ever rest on any human head. Put it in orbit around a failed star whose own reflected half-light does little more than throw its satellites into silhouette. Occasional bloody highlights glinted like dim embers from its twists and crannies. They only emphasize the darkness everywhere else. Imagine an artifact that embodies the very notion of torture, something so wrenched and disfigured that even across uncounted light years and unimaginable differences in biology and outlook, you can't help but feel that somehow the structure itself is in pain. Now make it the size of a city. Now, sometimes Peter Watts, the author of this book, I think his writing can be quite dense, but I actually find that quite an evocative description of this moment of first contact. It actually inspired this tattoo. Describing this thing, Rorschach. Now, I want to read another short passage. Ooh, something's going on. From a little bit later in the book. They've been observing this thing, Rorschach, for a couple of weeks, and the main character goes to see the captain. This is what he sees. He had surrounded himself with faces. Disembodied holograms floated in silent tears around him. Half a dozen real ethnicities and twice as many hypothetical ones. Skin tones ranging from charcoal to albino, brows high and slanted, nose splayed or pointed. Sarasti had called the entire hominid tree into existence around him, astonishing in their range of features, terrifying in their consistency of expression. A sea of faces rotating in slow orbits around my commander. What is this? Statistics. Sarasti seemed focused on an Asian child. Rorschach's growth allometry over a 2-week period. Their faces. He nodded, turning his attention to a woman with no eyes. Skull diameter scales to total mass. Mandible length scales to EM transparency at 1 angstrom. 113 facial dimensions, each presenting a different variable. Principal component combinations present as multi-feature aspect ratios. He turned to face me, his naked, gleaming eyes just slightly sidecast. You'd be surprised how much gray matter is dedicated to the analysis of facial imagery. Shame to waste it on anything as counterintuitive as residual plots or contingency tables. So think about what this is describing. This is describing a user interface. This is describing a method of data visualization. The idea is they have lots and lots of data that they need to look for patterns in, try and understand. Rather than trying to plot it as a graph, instead, they encode it as faces. They change the shape of the faces based on the data. And I was fascinated by this when I first read it. It seemed like such a science fiction idea. But it turns out this is actually not a science fiction idea, even though I read it in a science fiction book. This was actually described by Herman Chernoff in, well, we've got this now, lovely. This was described by Herman Chernoff in a paper in 1973. The use of faces to represent points in k-dimensional space graphically. His idea was very, very simple, exactly as the book said. We've got all this data. Rather than trying to graph it, what if we encoded this data as faces? Could we use this to gain insights on the data? Because, hey, we're really good at understanding faces, generally speaking. There's a little asterisk there, we can talk about that later. So let's do a little test. This is some data, okay? So each row is a record, each column is a data point. I'm going to count to 5, and I want you to look at this data and see if you can see any patterns, maybe interesting clusters, things that we should investigate or understand and dig into further, okay? 5, 4, 3, 2, 1. If the screen says, okay. Did anyone see any patterns? Just hands up if you saw any interesting patterns. Okay, so a couple of hands went up there. Now, let's try the same thing with Chernoff faces. This is literally the exact same data, but encoded as these Chernoff faces. Same test, 5 seconds. Tell me if you can see any interesting clusters here. 5, 4, 3, 2, 1. Hands up if you can see any interesting patterns. Now, there's some more hands going up here. See, you can see these guys over here. They've got kind of an intense stare, not sure what they're angry about. These guys over here, they seem somewhat happy, eyes high up. And these guys, we've got big, wide, happy faces, right? There's probably more that you could understand. See, what's happening here is you're actually using a fundamentally different part of your brain. I think the best way to explain this is with this picture, okay? If I ask you how many marbles are on the screen, you all see 1. Same if I do 2 or 3 marbles. You all see 3 marbles. None of you counted them. None of you went 1, 2, 3. But if I show you 10 or 20 marbles, now you have to stop and count. Now you're using your conscious mind. You're using a fundamentally different and, in fact, slower part of your brain. This is known as pre-attentive processing. There are overlapping ideas. You might also hear this called unconscious cognition or subconscious processing, or if you're Kahneman fans, this is System 1. If there's neuroscientists in the audience, I'm aware these are not all exactly the same idea, but they overlap enough. And that's the idea with Chernoff faces, is generally speaking, we're very good at processing facial imagery. So let's take advantage of the fact that we can do that almost unconsciously. And when I was reading the original Chernoff face paper, I stumbled across something quite interesting. In 1973, when this was done, the cost of drawing the faces was about 20 to 25 cents per face. Now, this is in 1973, and since then, computers have gotten at least twice as fast. So I think we could probably do better than this, right? And it just so happened that I was messing around with some data recently. Actually, when I was reading this paper, I was messing around with this data set. This is known as SATCAT. It's a huge open data set compiled by this guy, Jonathan McDowell, of every single object that humans have ever put into space. And I, for some bizarre reason, was trying to graph some things, trying to just do a little bit of analysis and get some insights out of this. And I wasn't having a fantastic time. So I thought to myself, what if I used Chernoff faces? So I did the obvious thing, and I stole some code off the internet. It was unlicensed. I have no idea if I could use it. I threw the data in, and I got a bit of a weird response. How many of those actually look like faces to you? So I think on a scale, we've got sort of roughly like a face on the left over to I have no idea what's going on over here. Okay? And this is especially frustrating for me because I had access to the code and I still couldn't figure out what was going on. So I decided to rebuild it from scratch. I actually went digging on the internet because I was very frustrated. This was my feeling here. So I went digging on the internet. I found some of the original documentation talking about how to construct these faces. I did not follow this perfectly, but I spent a bit of time. I spent a few afternoons messing around with Python and trying to visualize faces. And one of my first learnings doing this is that faces are really difficult. If you go back through my Git history, you will see me sort of slowly losing my mind trying to visualize faces, but I actually think I did okay. They're certainly not photorealistic, but they're roughly recognizable as faces. Now, for every 10 good faces, we still get, one or two, not sure what's going on with that, but okay. So, I had built this, I'd plugged it into the graphing and the data analysis tooling that I was using, and I started throwing data at it. I also updated it so I could map specific features to specific variables in the data, and I started seeing what I see. I started throwing random data at it and learning things. Here's a specific data set I saw. Now, there's a couple of interesting things you can see here, a couple of interesting things you can learn. First of all, there's a lot of garbage bags in space. Turns out, if you throw garbage off the space station, it'll just burn up in a few months. So it's actually a surprisingly environmentally friendly way of dealing with it. So we've got all of these garbage bags, and then we have these big faces are actually space shuttles. So it makes sense that the garbage bags are small and the space shuttles are big, and this is some pretty advanced aerospace engineering here, but generally speaking, garbage bags are smaller than space shuttles, so it makes sense. But what this does is this creates a sort of bimodal distribution. We have all the small things on one end, all of the big things on the other end, and it sort of squashes out all the details. It's very difficult to get fine detail out of this. So I learned that this is probably more relevant for cluster analysis or comparable data, possibly time series, seeing how something changes over time rather than comparing two completely different things. So I learned that, and I went on a little bit. Here is a selection of space shuttle missions. Okay? I think that if you spend a little bit of time looking at this, you can see some patterns here. No numbers, just purely by looking at the faces. I would divide the faces like this. The ones down here, they're big, round faces. They all have roughly the same expression. And the ones up here, these are differently shaped, different expressions. So, turns out that all of the ones down here are missions to the space station, which is in the same orbit. They're taking roughly the same amount of stuff to the space station, so they all look roughly the same. And the ones up here, well, the first one, this is the launch of the Hubble Space Telescope. This one here is the first servicing mission to the Hubble Space Telescope. This is the third servicing mission to the Hubble Space Telescope. And this one over here is the Compton Gamma Ray Observatory. These are actually all members of NASA's Great Observatories program. These were heavy payloads, but launched to very different orbits, so you can see how those faces are somewhat different. You can actually tell how they're clustered purely from how those faces are somewhat similar. Now, I think that's really interesting, but I think the more interesting thing here is that's not pre-attentive. You don't see that in a fraction of a second before your conscious mind gets to it. You've really got to process this stuff. And it turns out the authors of this paper noted the same thing. They found that Chernoff faces are actually mostly not pre-attentive. This is the whole pitch of Chernoff faces. We're using a different part of your brain, but actually you're probably not doing it. They go on further and they say that specific features like eye size and eyebrow slants come out and make it easier for people to see the differences. I actually disagree with them on this one. I don't think it's specifically eye size or eyebrow slant that is important for processing this data. Look at these two faces. I am willing to bet that the first thing you noticed on these faces is not the eye size or eyebrow slant. you notice their expressions. You notice that this one here seems pretty gormless and happy. This one here seems a little bit skeptical. You're not processing the pieces, the parts of the face individually. That is not what you're doing pre-attentively. You are seeing expressions. It's actually in the original piece from the book. Principal component combinations present as multi-feature aspect ratios. We call those expressions. That's what expressions are. They're combinations of parts of your face moving in specific ways. Which means Chernoff faces are probably not great for very large data sets either. These aren't mine. These are from the folks at Wolfram Alpha. So my learnings, messing around, spending a couple of weekends messing around with Chernoff faces, were that the faces may, in some cases, help us see data at a glance. They may make the first step easy, but that second step, really digging into the data, and that's very often the really important step when we're trying to analyze data, when we're looking at a dashboard or something like that. It's that second step that really matters, and they're kind of bad at that. They're probably more relevant for time series or cluster analysis, and they're probably only useful for relatively small data sets. So it turns out, after all this work, I basically just reproduced the findings of the original paper from 1970. Said it's useful for a first look approach and might be useful in cluster analysis or time series. So I spent a couple of weekends reproducing some work from the 70s. Good job, Steve. Other people have done this too. This is the folks from Wolfram Alpha. They experiment with colors. I'm not sure that's a good idea personally. They've got this big data set here. Now, look, you're probably looking at these faces and thinking, Steve, these faces are great. I love looking at them. But we now live in a world of man-made horrors beyond our comprehension. Surely we could create photorealistic Chernoff faces. And unfortunately, you're right. People have done this. I'm not going to talk about this. I will leave this as an exercise to the watcher, whether or not this is a good idea. I've got to wrap up now. So what was the point of this talk? I've spent a lot of time talking about weird interfaces in science fiction and Chernoff faces. I shared with you the specific learnings I got from Chernoff faces, but the reality is you're probably not going to be using Chernoff faces in your next project. I personally do a lot of data visualization with Datadog, making dashboards, and Datadog offers lots of widgets for visualizing data, and currently they do not offer a Chernoff face widget. My feature request is, I think it's pending, so we'll see. There's someone from Datadog here today, so I'm going to follow up with him, but you're probably not going to be using Chernoff faces. I could try and generalize some of these learnings. I could talk about how pre-attentive processing is incredibly powerful, but also you really need to understand where it doesn't apply. It's not always as intuitive as you think, and you also need to remember the cost of that second step, what it takes to really dig into that data. I think these are useful things to learn. I could also send you to books like The Visual Display of Quantitative Information, right? The classic by Edward Tufte. It's probably got those learnings in there somewhere. I could recommend a bunch of neuroscience books to you. I could recommend the book Make It So, which is a whole book about user interfaces in science fiction, exploring their practicality. I think it's a fun, good book. But really, I want to encourage you to just go out and build things. We're surrounded by science fiction movies. We're surrounded by influences, interesting, shiny interfaces. What would happen if you turned this into a login page? I think you should try that. What if you turned this into a dashboard? Would that work? How would that work? I don't think it would work. What about this as a sign-up page? Who knows? Look, these are almost all terrible ideas. I'm confident in saying that, but I think you should try them anyway. I don't need to tell anyone here the value of prototyping, the value of building a mock-up and just seeing what happens. I'm sure everyone here has built a mock-up of a well-thought-out design, but I want you to go out and build something stupid. I want you to go out and build something really wild and interesting, because that's where you're going to go down the rabbit holes. That's where you're going to learn things that you didn't expect. Really, my message today is fuck around and find out. Just go build some things and have fun learning. Thanks.